Okay guys, welcome to the other tutorial. Today we're going to be doing the counter smart contract development for Near protocol. Before we do, I'm going to mention that we're going to start setting up our projects now using npx create near app. The reason why we're going to do this, actually there's two reasons. One is that we can create the Near app and declare the contract that we're only going to be building the backend. So because we can set the front end to none. And there's a second reason, which is if we check our smart contracts hello, the one that we wrote in the previous tutorial, here's the two versions. One, the way which we created it with just cargo, and the second one using this npx app generation command. So if we go into the one that we wrote by ourselves in the last tutorial, and we check the target, that one that was compiled, the WASM file, I checked the size, it's 1.8 megabytes, which is quite a bit. And if I check it now, the other one, the one that was created by the npx command, and go into the contract target on WASM32 unknown release and check the same WASM file, over here we only have 105.7 KB. So it's a lot smaller, and obviously it will cost a lot less to host it on the Near network. I don't know exactly what causes this file to be smaller, probably some settings in cargo when the library gets set up. I'm gonna have to take a look into it. But clearly there's a good reason to use the npx create near app, so I would recommend using it from here on out. Okay, so without further ado, let's get started and start creating our new smart contract for counter. So I'll just copy all. Actually, I'm just going to move this to the side so that I can just see it. And let's go. So I'm going to list. I'm inside the environment right now, inside the Near contracts, our tutorial folder. So let's begin. We're going to do npx create near app. We can actually add latest to it so that we get the latest version. And then we do the project name, so we're going to do counter I'll just do counter without the contract. And then I set -- contract. Which language we're going to use? We're going to use Rust. And then the front end -- front end. This one we're going to have none. And we need to also set tests, because all these flags need to be set. Oops, not yes, I need tests. Can't type. And we're going to just set this to Rust as well. And enter. Now if we list, we have the counter directory here now. Let's go inside it. So we're inside our counter directory. If I list all the stuff, and here we have a package.json, so let's view this package.json. Over here we have commands on deploying, building the contract. We're actually going to modify these commands a bit, same as we did in the previous tutorial. Okay, now let's open our programming IDE and start working on our contract. Okay, so over here we have this contract directory and integration test directory, the packages that we just looked at. What we're interested in, we need to go to contract, and over here we have source and librs. Now, by default, we have this package. It's actually the hello contract template, same as the one which we were developing in the previous tutorial. I'm actually going to change this. We need to replace a lot of code and to make it into the counter. However, we should also rename the package as well. Over here it's still called hello near. I'm going to change it to counter near. Save it here. And in the package JSON, hello near. I'm going to switch it to counter near. Okay, the renaming is done. Now I'm going to switch out all of this code for our counter code with a little bit of a modification. So the counter code, we're importing Borscht again for serialization. We're importing near SDK. We are creating a struct of a counter with a value set to signed 8-bit integer. Then we are implementing a counter trait with 5 methods. By default, if you check the default code for the counter for near examples, you will have only 4 methods: the get num, increment, decrement, reset. There will not be any set command. Set command sets the value directly to the integer that we pass. And there's a reason why I've made it. We're going to take a look at it in a moment. So over here, get num clearly just gets the number value out and returns it. Over here, we're incrementing the value by 1, decrementing value by 1. Here we just reset it to 0. And here we set it to whatever number that we want. Have to pay attention to the set2 variable. Actually, I'm going to set it to VL. So it's like a VL is just like a value. The reason you need to pay attention to this is because by default the values are actually passed as strings. So we need to convert them into actual data type that we want. In this case, it's an assigned 8-bit integer, and that is why we're running this kind of command. Okay, so let's try compiling this contract and see what happens. Actually, first we have to change into the contract directory. It's the same directory as we have our toml file in, and then we will paste this command rust-up target add wasm32 unknown unknown. After this, we will actually compile it. Let me clear this and paste it here. So cargo build all target wasm32 unknown unknown release. Our release has been installed. Now, let's check the size of this file. One of 4.8 kilobytes. Pretty small compared to 1.8 megabytes, won't you say? Now, let's create an account in which we're going to store this contract and deploy the contract to the account. So our parent account is going to be a.test.near, same as in the last tutorial. So let's do near create account. So let me clear the near create account counter .a.test.near, and then we're going to be master account a.test.near, and we need to specify initial balance as well. I'm going to specify it to 5 near and create the account. The account has been created. Now let's try to deploy our smart contract to this account. So to do this, near deploy wasm target wasm32 unknown unknown. Over here we have to change this to counter. And account ID is going to be counter .a.test.near, and let's try and deploy it. Now let's use our postman in order to see if we get any kind of return from here. So in the postman, I have this RPC request set up to localhost at 8332. Our content type is set to application JSON, and our body is the same request as we need to do to send to the RPC endpoint in order to get some kind of result. So over here you see the account ID that we're requesting is set to counter.a.test.near. So let's send it and see what happens. We get some sort of response, but notice this area right here, values, it's empty. So there's nothing there now. Let's try calling some smart contract methods using our CLI. So near call, I'm just going to do a little help. So we need to call contract name first, and then so this is the account of where the contract is stored, the method name, the method that we're calling, and then this in the form of JSON. If we're not passing anything, the JSON should just be two curly brackets, open, close. Let's go ahead and run get request. Let me actually put this here, make it smaller, just so that we can see what we need to submit. So near call counter.a.test.near get num, and specify an empty curly braces here inside the quotes, and then we need to specify the account ID of who is signing the transaction. I'm going to do it using the b.test.near. And the transaction went through, and we returned 0 because 0 is considered to be a default value set inside this default. By default, it's 0, even though we didn't set it to any value yet. Now let's do an increment and see what happens. Going to run an increment. And now let's check what does getNum give us back. GetNum returns 1. Now let's see if we get 1 using this postman here. So let's do a submission. And now we see that values, there is some sort of value in here. Let's do a decode of both of these, both of this gibberish here. So I'm going to switch into our base64 decoder, paste this and decode it. So this still says state, and let's see the other one. You'd think that it should return a 1, right? Let's see if it does return a 1. Well, apparently not. It returns some weird symbol right here. So what is actually happening here? Okay, let's go to the ASCII table and see what is actually going on. When we are submitting things to the blockchain and it gets serialized, this is exactly what it looks like to the computer. A bunch of zeros and ones. And in our case, with an assigned 8-bit integer, value 1 actually looks like this. However, when we are decoding and trying to see what the value actually is, it doesn't know what character this is, because in the ASCII table, this doesn't connect to any sort of character. However, if we set the value to 49, meaning in the bit form, in the binary form, it will be stored this way, it should actually show us a 1. Let's try that and see what happens. Let's set it directly. So I'm going to do, instead of an increment, I'm going to do a set. I'm going to specify it was a VL, and I'm going to set it to 49. Notice that I'm passing a string. However, this string is going to be converted into an actual signed 8-bit integer, as we saw here, when we are parsing it into an I8 type. So let's run this code and see what we get. So over here we get, if we look at what it is saved as, It is saved as 49. However, that's an integer type, right? But over here, if we go and I'm going to get the value and copy this, paste and decode, we get a 1. See, because this is a character. That is an integer. So the values are different. The representation inside the computer is different. So because of this little bit of computer science stuff, this is why we have this happening. Let's try and increment it and see what happens. I'm going to increment it. Now let's just use a different account, let's say, and I'm going to do increment. And let's return the value, get num. Over here we get 50. Let's go through Postman and get this value again. What does it mean here? It's a 2. And no surprise here that that's a 2, because after 49 we have a character 50, which in string representation in the computer it's actually a character 2. Okay? Let's just check the rest of our methods and wrap up this tutorial. I would like to mention that right here I used a different account to run an update. So we used to use B, but now we use A. And if I do any kind of change, let's say if I do decrement using an A account, it will change. And if I check for get num using a B account, it will still return a 49. Sorry, because we had a 50 here, so we decremented by 149. So no matter who calls these public methods inside of our code, they will update the general state. They do not have a compartmentalization of any sort for their account to store values. That is something that we're going to have to work on in the future tutorials. Let's run our last method. We're going to call reset. Reset. The account that's going to call reset is going to be B. And then we're going to get the value with an A account. And it should be 0. There we go. So all of our methods work. We saw the peculiarities of storing values in the serialized format, because this is sort of what it is stored as. There's a bunch of zeros and ones in the binary with a different character representations for different values. And that's it. So this is it for this tutorial. In the next tutorial, we're going to start working on the guestbook example. On the Near website, we only have a version written using assembly script. And what we're going to do is we're going to take this and write the same smart contract using Rust programming language. So stay tuned for that. Other than that, don't forget to like, subscribe, share. That would help me move along the channel. And thanks for watching. See you next time.